Now, for standard 10 in polynomial, the next part is if two zeros are given, then find the quadratic polynomial. Suppose two zeros are given 3 and 5. Find the quadratic polynomial. For that, the formula is required polynomial or required quadratic polynomial is x square minus alpha plus beta into x plus alpha beta, where alpha and beta are the zeros. It means of which polynomial zeros are given, their sum of zeros required and product of zeros required for the quadratic polynomial. Now, the questions are, if alpha and beta are the zeros of the polynomial x square minus x minus 6, find a polynomial whose zeros are, their zeros are 2 alpha minus 1 and 2 beta plus 1. 2 alpha plus 1 and 2 beta plus 1. It means now we will find out a quadratic polynomial whose zeros are 2 alpha plus 1 and 2 beta plus 1. That was the first question. Second question is alpha by beta plus alpha by beta comma beta by alpha. It means find a quadratic polynomial whose zeros are alpha by beta and beta by alpha. Third one is alpha minus 1 by alpha plus 1 and beta minus 1 by beta plus 1. Now, first you try to understand the question. Alpha, beta are the zeros of this polynomial. It means sum of zeros and product of zeros can find out easily. From that relation, now we will find out the sum of this zeros and the product of these zeros. Then we will get the required polynomial. So first, since alpha and beta are the zeros of x square minus x minus 6, therefore alpha plus beta is equal to minus b by a. So this can be written as minus 1 by 1, so that is 1, and alpha beta c by a, so minus 6 by 1, that is minus 6. Now these two values are available. By using this values, now we will find out one by one. First, sum of zeros and product of zeros value. Similarly for the second question also, and similarly for third question also. Now, first question. Sum of zeros, that means 2 alpha plus 1 plus 2 beta plus 1. Now this can be written as 2 into alpha plus beta plus 2. Alpha plus beta, how much? 1. So 2 into 1 plus 2, that is 4. It means now we get sum of zeros of required polynomial. Similarly, product of zeros is equal to 2 alpha plus 1 into 2 beta plus 1. Multiply these two. So 4 alpha beta, 2 alpha into 1, that is 2 alpha, 1 into 2 beta, that is 2 beta plus 1. So now 4 alpha beta plus 2 common, alpha plus beta plus 1. Now 4 alpha beta value is minus 6. So 4 into minus 6 plus 2 into alpha plus beta 1 plus 1, that is equal to minus 24 plus 2 plus 1. So 3 minus 24, that is minus 21. So now we'll get both values, sum of zeros of required polynomial, product of zeros of required polynomial. Therefore, required polynomial is x square minus sum of zeros, that is 4, into x plus product of zeros. So plus product of zeros is how much? Minus 21. So it is minus 21. This is required polynomial. Similarly, now we can find out for this second question. Second question, the zeros are given alpha by beta and beta by alpha. Similarly, now we will find out first sum of zeros means this plus this, product of zeros means this plus this value, and then we will get the value of quadratic polynomial. So now second question. For second question, sum of zeros is equal to alpha by beta plus beta by alpha. Now that can be written as alpha beta plus alpha square plus beta square. Now alpha square plus beta square value, alpha square plus beta square can be written as alpha plus beta whole square minus 2 alpha beta by alpha beta. Now alpha plus beta is 1. So 1 square is 1 minus 2 into alpha beta is minus 6 by alpha beta minus 6. So now this is equal to 12 plus 1, 13. So minus 13 by 6. So now this is the value of sum of zeros of for this required polynomial. Similarly, product of zeros is equal to alpha by beta into beta by alpha, that is 1. So therefore, required polynomial is x square minus sum of zeros. So minus minus plus 13 by 6 x plus 1. That is the required polynomial. Similarly, for the third question, the zeros are given alpha minus 1 by alpha plus 1 and beta minus 1 by beta plus 1. So first we will find out the sum of these two zeros. That value can find out by using alpha plus beta 1 and alpha beta minus 6, because this is the sum and product of zeros of original polynomial. So for third question, again find out one by one sum of zeros and product of zeros. So third question is sum of zeros is equal to alpha minus 1 by alpha plus 1 plus beta minus 1 by beta plus 1. Now take the LCM, alpha plus 1 into beta plus 1. Now alpha plus 1 cancel, so alpha minus 1 into beta plus 1 plus beta minus 1 into alpha plus 1. Now multiply this one, alpha into beta, alpha into 1, that is plus alpha. Now this one, beta into 1 minus beta and 1 plus beta into alpha, alpha beta plus beta minus alpha minus 1 whole divided by alpha beta plus alpha plus beta plus 1. Now alpha beta plus alpha beta, 2 alpha beta plus alpha plus beta. So alpha plus beta. Now you see here minus alpha minus beta. So minus sign or can uh, minus sign take easily, it will be cancelled out actually. Now minus alpha minus beta plus beta cancel. So now 1 plus 1, sorry, plus 1 minus 1, this one also, no, here it is minus 1 actually, minus 1 alpha beta plus alpha minus beta minus 1, sorry, and minus 1, so minus 2 by alpha beta plus alpha plus beta plus 1. Now 2 alpha beta, so 2 into alpha beta is minus 6, so 2 into minus 6 minus 2 whole divided by alpha beta minus 6 plus alpha plus beta 1 plus 1. Now that is equal to minus 12 minus 2, so minus 14 by minus 6 plus 2, that is minus 4. So that is 7 by 2. Now 7 by 2 is the value of sum of zeros of required polynomial. Now we will find out the product of zeros. So product of zeros is equal to alpha minus 1 by alpha plus 1 into beta minus 1 by beta plus 1. Now that is equal to alpha beta minus alpha minus beta plus 1 by alpha beta plus alpha plus beta plus 1. So now this can be written as alpha beta minus sign common alpha plus beta plus 1 by alpha beta plus alpha plus beta plus 1. Now alpha beta minus 6 alpha plus beta 1, so minus 1 plus 1 whole divided by alpha beta minus 6 plus alpha beta plus 1 plus 1. Now this is equal to minus 6 by minus 4, that is 3 by 2. So sum of zeros 7 by 2 and the product of zeros of required polynomial 3 by 2. Therefore required polynomial is x square minus sum of zeros, that is minus 7 by 2x plus product of zeros, that is 3 by 2. So this is the required polynomial if the zeros are this and this. So common question is, if alpha and beta are the zeros of any particular quadratic polynomial is given, then after that your question is given like this. Any zeros are given in the form of alpha and beta. So the main question is, first you will find out the sum of zeros, means alpha plus beta and alpha beta for the given quadratic polynomial. By using that value, find out sum of zeros of required polynomial and product of zeros of required polynomial, and then use the formula x square minus sum of zeros into x plus product of zeros. For that, in that way, find out the values of sum of zeros and product of zeros. Maybe sometimes you require the identities concept. So identities concept is also very important. So now today quadratic polynomial topic is completed.